thank you very much, Mohammed, and thank you for this initiative. So you prefer English, isn't it? Okay. So I'll be talking about ethics and trustworthy AI. I'll be touching healthcare, and my approach is sensitive data oriented. I know many presentations were technical. Ethics is a little bit related to governing AI. So my outline will be like this. After an introduction, some terminology definition. Then I'll be talking about ethics of AI, for AI, and in AI, which is not the same thing. And also I'll be tackling ethics, AI ethics frameworks. And then I'll be a little bit criticizing those frameworks and giving some perspective, some research perspective on AI governance and AI ethics. You know Timnit Gebru? Okay, so Timnit Gebru has said, ethics without justice is just white supremacy. So we are in French Moroccan summer school. So we need to take into account the culture, ethnical aspects, etc. Because it's not just data and algorithms. There are many things to take into account. Just some word about data governance. What is data governance and what is AI governance? So this is a diagram from DAMA. DAMA, which is an international association dealing with data management. So it's data management association. And you have a chapter here in Paris. So according to DAMA, data governance is related to many dimensions. Either data quality, data architecture, data modeling, data storage and operation, data security and compliance, data integration and interoperability, document and content management, reference data management. So there is reference data and master data, which is two different things. Of course, making decisions from information and from data, and metadata. What we mean about metadata is data on data. When we annotate data for training, your annotation is metadata. When you describe your data dictionary, it's metadata. But also when you classify that this data is personal, this data is sensitive, this data is biometric, this data is profiling sensitive, it's metadata. And this metadata can help tagging data, can help cataloging data. We talk about cartography, data cartography. We talk about data lineage. If you have some data that is sensitive and there is some script or some pipeline related to this data, donc, we talk about tag propagation. So there is data lineage, and those tags will be propagated through your pipelines, so you can infer some security rules. you can be able to do some compliance testing, not just about the initial data, but about all dependent data, scripts, pipelines, models, weight, etc. And if you do not do this, you are not governing your data. So this is data governance. We are in summer school about AI. So there is another level, which is AI governance. Before talking about AI governance, I would like to define trustworthy AI. So according to European Union ethics guideline, trustworthy AI is legal AI, so AI that is compliant to regulations, ethical AI, we'll talk about this deeply, and technically robust AI. Here we talk about security aspect, technical aspect, about robustness. I will talk about this also. You know, GIGO anti-pattern, garbage in, garbage out. So if you have garbage data, even if you have state-of-the-art optimized AI models, you will get garbage decisions. And of course, unreliable, invalid outcomes, impact. So here we have bad data governance. But even if we have good data governance that will yield clean data, even with state-of-the-art optimized model, you can get dirty decisions and harmful, unfair, opaque outcomes. Data governance is not sufficient. You need AI governance. And I will define what is AI governance. So with good data governance and good AI governance, we hope that with clean data, with state-of-the-art optimized models, you can get clean decisions and trustworthy AI. So it's a couple of data governance and AI governance. So if data governance deals with data quality, data security, data privacy, data bias and fairness, data provenance and transparency, AI governance deals with AI model transparency, explainability, AI model validation, AI model risk management, AI model ethics, and social responsibility. So you need both of AI, data, and AI governance. So you know about bias. I will not talk again about bias, but just give some example. Here we talk about cultural bias. So here we have within images, but this image is scored like banal people photo. It's not detected as within image because the model is trained on very standards wedding photographies. We have gender bias. Some old version of Google Translate. Now, if you test this, it will not. It will work. But before, if you translate, she is a programmer, he is a nurse, to some ambiguous translation or ambiguous language in Turkish, you can have some ambiguous sentence like, we do not differentiate between she and he. And then when we translate back the Turkish sentence to English, what we get, he is a programmer, she is nurse. Because statistically speaking, there are more men programmers than men nurse. And there are less women programmers than men programmers. Of course, This is very old version of Google Translate, but this is gender bias. UNESCO says that 22% of data scientists, only 22% are women. So it's not just the bias of the data, but the bias also of the technical teams. Ethnic bias. I don't like racial bias, because in literature you will find racial bias. We have just one race. Robert Julian Borchak William, you can search for him, and he was, en français on dit c'est un bisounours. Look, I mean, he cannot be criminal. Robert Julian Borchak Williams was wrongfully accused and arrested due to the use of AI facial recognition. I will keep this slide available, so you will have details. And there is one system called predictive police. So in Europe, if a judge can use predictive police system, there are predictive police systems in Europe too, but the judge remain sovereign. But in United States, if the predictive police system decide that you present a risk, so the judge should take this into account. The guy, the left guy, is a real criminal. The predictive police has scored him with level 3, and the right woman, okay, she had some little crimes, but even if there is no little crime and big crimes, but compared to the guy, she is less criminal in reality. But she has been scored at level 8 because of the délit de faciès, because of statistically there are more black people in American prisons than white. This is statistics. But also because of gender bias. Socioeconomic bias. I told about Netherlands that have been using social scoring to deliver allocation familiale or social allocations. I will not talk again about it, but people become homeless after being obliged to give back money to the government. 20 years of allocations, they have to give them back, so give it back, so they have to sell their homes, and they just become homeless. So bias can have very, very, critical impact on society. Fairness is the issue of treating different groups equally, such as different gender, having similar rule approval rates in the training data set or in the recommendation of AI model. So if there is bias, we will not have fair models. This graph shows AI ethical incidents and evolution of AI ethical incidents. So there is some database called AI incident database, okay? And by ethical incidents, for example, autonomous car causing pedestrian fatalities or facial recognition systems leading to wrongful arrests. So this is considered as AI incident. So look of this evolution curve. And we are just in the beginning. So the NIST, yesterday Fabrice told about NIST, which is standard in technology institute in the United States, and the NIST has classified harm related to AI to 3 kinds of harms: harm to people, harm to an organization, and harm to an ecosystem. I told about technical robustness. Do you know different type of security attacks to AI system. Again, NIST. NIST talk about three kinds of attacks. Either attacks to the training data set or attacks to the test data set, or not three, but four. Attack of the training data set is called poisoning. And we can also attack the models, the weights of your neural system. It's called code poisoning. The second attack is evasion. It is the attack of the testing data set. Let's say we have some cameras and we inject some noise during the data collect in runtime, and this is called evasion. And I will give example. And you know Tay chatbot? No? It's ancestor of ChatGPT. It has been launched by Microsoft in 2016, and it has been decommissioned in 24 hours because it could learn from users in runtime. So users can inject bad data, and so the chatbot learned from this data, and it becomes racist in 24 hours, which is not the case of ChatGPT, which simulates that it learns from you, but it is just session-oriented learning. It does not change other interaction with other users. And this is a poisoning. So there is poisoning attack and evasion attack. Either the poisoning attack is learning from bad data initially, because it has learned from some politically oriented parties' data initially. So it was like easy to become a racist, because from the beginning it has learned from very, very specific data. And evasion, which is the learning from runtime user interaction. Of course, ChatGPT, we do not know about poisoning because it's not transparent, and we don't know what is the data that it has used to learn. But you cannot make evasion because it's controlled with Big Brother, either robots and human workflows. Again, here, evasion. You have here some medical images, and we can inject some noise invisible to human, and you change radically the scoring of these images. So all those images have no concern. But with injecting noise that we cannot, perceive easily, you can change the classes of your images. So this is evasion attack. And so robustness, technical robustness, which is part of trustworthy AI, is to be able, so the model should not be sensitive to this poisoning and to this evasion. Two other attacks are privacy attacks and abuse attacks. Abuse attacks is making some bad or fake data flooding on the digital universe, not directly related to the training data, but just flooding the web with fake data, etc. And indirectly, you will impact training data of models. So this is abuse attack. Privacy attack is to just listen to some machine learning pipelines and to know how it works, and to planify some security attack later on, comme les bombes à retardement, like malwares. So you just listen about privacy, and then you planify some evasion or some poisoning attack. For example, you have some drones or some cameras or some sensors, and you learn about how they work, and then you find some problems, some security problems, and then you planify some attacks. You know about explainability, transparency, auditability, and accountability. Okay, you know about those terms? No? So explainability, you know all about this. Okay. Transparency, okay. You need to know, for example, ChatGPT is not transparent. We do not know the data, training data. We do not know pipelines used to training. We do not know the code. DeepSeek at the beginning try to open the code, but then keep the code not open source. This is part of transparency. There are some proposals to make data used to train some model open to prevent some, for example, poisoning data. So you make your data open, so the community will help you to validate your data, so you are transparent. So if you have your data, either you are non-transparent or you don't want people to criticize your data. So keep your data as open as possible. Auditability means that the ability to trust how the system is working by having some logging, explicit logging, to be able to measure some KPIs about how the system is working. So mainly logging attitude. And Youssef Gahi, Professor Gahi, will talk about auditability in his talk. Accountability, that means that to highlight who is responsible for each decision. It is designer responsibility, algorithm responsibility, data collection responsibility, or data collector responsibility, eticians responsibility, security expert responsibility. Who is responsible when the model gives bad decisions? So, as I told you, the ethics approach is privacy oriented. You know about PII and SPI? Who do not know about personally identifiable information? You know about personal identifiable information? No? Okay. So, personal identifiable information are information that can identify an individual when it is used alone, directly, or with other relevant data, indirectly. So, for example, your name identify you directly, but your IP address identify you indirectly, because we have to use your IP address and other logs to know that it is you. Name, surname, email, phone number, photo, IP address, postal address, cookies are all considered PII. So SPI, it is a subset of PII, but it is more sensitive. The sensitivity comes from the fact that this personal data reveals either ethnic origin, political opinion, religious or philosophic beliefs, trade union membership, health identifiable information, health information which is not identified, linked to some person, is not sensitive. But when health information is related to PII, it becomes sensitive. You understand this? Genetic data, government identifiers, like security, social security numbers, driver license number, passport number, ID, financial account number, credit card number, medical analysis related to identifiable person, political opinion, sexual orientation, biometric data, all these are considered SPI. But I'll dive in this SPI class because it's a huge class. And if you are doing deep learning modeling without controlling what we are using as data, I mean, we can suffer from attacks, we can suffer from AI incidents, and we can be induced anti-patterns. So, what is protected health information? So, protected health information, specific sensitive information. Not all sensitive information are health protected information. So, health information, allergies, medication, family medical history, mental pathologies, etc., etc. But when it is related to identifiers, it becomes PHI. If it is not related to PHI, it is just medical anonymous information. So not sensitive. When it is linked to some identifiers, here it's becoming sensitive. So in the slide, I will let the slide available and we'll have details, etc. So here I come to biometric sensitive personal information. You know about biometric information? Yes? Others? What are types of biometrics? What are types of biometrics? There are two types of biometrics. Either biological biometrics and behavioral biometrics. Okay. When I use my keyboard and I am entering my password, this is called advanced authentication. And this is behavioral biometrics. Okay? It is not biological. The fingerprint is biological biometrics. Biometrics identifiers are subset of SPI, and it's very, very rich domain. Palm veins, facial features you are using in deep learning facial recognition. Cycle of sleep. Of course, not all biometric information can identify in a unique way a person. So even if they are considered as biometric, but not of the same quality. Iris or retina are more viable than voice, for example. Voice can change. Okay. Frequency of brain waves, voice pitch, this can change. DNA, iris pattern and retina vein patterns. Fingerprint, just for the anecdote, this is a 43,000 fingerprint. So this is a very, very old fingerprint that has been discovered recently. Palm geometry, palm print, signature, okay. Case stroke. So this is behavioral. Gait cycle. You know that Bin Laden has been detected from satellite images with the gait cycle, which is indirect sensitive personal information. Just with satellite, we do not know the guy, we do not see the guy, but we see his movement. And we could use videos of the guy and compare the gaits, and we could identify that it's him. You know that it's very, very critical information, behavioral information. When we talk about PII, SPI, generally we talk about known information, but inferred information is more critical. And AI are doing inference, prediction, measurement, and we do not know what it is inferring or predicting or measuring about us. Eye movement. Just from eye movement, we can infer gender, age, geographical origin, biometric identity, physical health, cultural background, mental health, personality trait, I will talk about, skills and abilities, psychology neurolinguistic, PNL, level of sleepiness, mental workload, cognitive processes, drug consumption. I give some references about this, and you'll find slide you can deepen on this. But it's, I mean, very, very huge, very, very huge domain. Of course, there are some biometric information that are very, very performant, like iris and fingerprint. The face can change. The hand geometry can change, the voice can change, okay? And the fingerprint is unique, so it's high in distinguishing person, but the face is not high as for distinguishing person. Iris is very interesting. Pitch or voice pitch is not interesting at all because it can change all over the day. And we can even see difference between iris and retina in distinguishing and in performance. So when we deal with personal information, we distinguish between personal characteristics like gender, address, income, profession, financial status, sexual orientation, etc. But we have also personal traits, observable or declared lifestyle, like hobbies, dietary preference, language, music tests. And this is coming from our behavior on the web. We can infer our personal traits. We can also infer our personality. So the personality is qualitative information. Charming, empathetic, neurotic, and the doctor has thought about this kind of aspects. But personality is different from personality traits, which is quantifiable. And here we are talking about the big five: openness, conscientiousness, extraversion, agreeableness, neuroticism, etc. And here we can measure some metrics. Of course, we have the protected health information we have talk about. We have behavioral traits, either behavioral traits and biological traits, biometrics. And we have collective identity. So collective identity, religion, sexual group orientation, community funds, political orientation. So we can deal with known characteristics, measured characteristics by sensors, inferred characteristics based on evidence and reasoning, predicted characteristics based on patterns. And of course, we can base prediction on inferences. The idea or the problem is that laws protect more known characteristics than inferred, predicted, measured characteristics. And there are many, many inferred, measured, and predicted characteristics than known characteristics. So when we choose, we give our agreement to collect our data, we agree that AI will infer all possible, but we are not protected. I mean, if I hide my personal information, I don't hide my keyboard using or other behavioral information. So within the PII set, we have SPI sensitive, we have protected health information, which is PII, but some protected health information are not that sensitive. Not all health information are sensitive. And we'll find the detail in the slide. Biometric data, either behavioral and biological, are part of sensitive information. And orthogonally to this, you have behavioral information and collective identity. I talked about behavioral, biometric behavior, but there are behavioral information that are not biometric. And collective identity, there is intersection with PII and SPI, but there are also collective identity that is not related to PII. Besides this, you have model-sensitive information and profiling-sensitive information. So you can, what is model-sensitive information? Model-sensitive information either used, influenced, or output from AI machine learning models. Okay? So when you use a model, your output is model sensitive. But when you are doing things manually, you can change your way of scoring things. So there is not one model. It's subjective. So when we use AI model, it is model sensitive. When we do things manually, it's not model sensitive because we do things in a subjective way. We can, make mistakes. We cannot do it, scientifically in a model-based manner. Providing sensitive information used to predict, assess personal of behaviors. So when we profile people, we talk about profiling sensitive. For example, here, manual investigation, human-based marketing segments, rule-based HR screening are profiling sensitive, but not model sensitive, because it's done manually. Psychometric profiling AI, facial emotion recognition, targeted political advertising are model sensitive and are also profiling sensitive, because we profile people and we use AI model. Here we profile people, but we do not use models. We are doing it manually. We can have model sensitive information that are not profiling people. For example, spam filter, demand forecasting, fraud detection, anonymized fraud detection. It's model sensitive, but not profiling sensitive. And we can have something that is neither profile sensitive nor model sensitive, like public weather dashboard. statistic news feed, not necessarily using AI model and not profiling person at all. So when we deal with personal identifiable information, we should know if we manipulate known data, if we infer, if we measure, if we predict other personal information or sensitive personal information, if we measure, predict, infer biometric, behavioral biometric, biological biometrics, if we manipulate protected health information, if we predict, infer, measure collective identity, behavioral identity, if we predict, measure, infer model sensitive information, profile sensitive information. So all those classes will help us to control our data, our pipeline, our conformity to laws, our security, our government. So here we have a presentation of personal threats, personality threats, behavioral threats, collective identity, with example for known, inferred, measured, predicted informations. And this information can either be PII, SPI, biometric, protected health information, and with sensitivity and regulation risk. So if you are, of course, doing AI models is difficult, but it is not sufficient. We need to know metadata about our data, our models, our pipelines to really govern our AI project. Here we are talking about resource-limited AI, isn't it? In this kind of concerns, privacy, frugality means data minimization. How we can conserve the same model accuracy by using the minimal personal data. That does not mean that we have to hide personal information, we have not to use personal information. It's not possible. But try to minimize personal information used in training. I will talk why. So, trustworthy AI is legal AI, respecting regulation, robust AI, preventing attacks, poisoning, evasion, abuse, privacy, and ethical. So what is ethics? There is ethics of AI. Ethics of AI means impact of AI on society, like reducing job positions. It's an impact on the society. It is ethics of AI. Ethics in AI, it's what we call ethics by design, embedding ethics measures within the system itself. For example, some fairness measurement within the system to be fair and to produce fair results, or transparency measurements embedded in the system. It is ethics by design. And there is ethics for AI. That means produce moral agents. For an autonomous car, how an autonomous car can behave morally, not to kill children. And Fabrice told about that in we change the culture, and maybe the moral values can change. And if children is priority for moral agent in our region, maybe elderly people are more valuable because government has invested a lot in elderly people, and it's we can kill children but not kill elderly people. So this is very subjective, but moral agents is to be taken into account. So ethics is multidimensional. And here I give you some references. You can deepen your research about this. So there are many ethics frameworks. Either UNESCO AI ethics framework, ethics guidelines of Trustworthy AI from European Union, EU AI Act from European Union, OECD Trustworthy AI or values-based AI principles, and we can back again to proportionality is data minimization. La proportionnalité. N'utiliser que ce qui est nécessaire pour. Est-ce qu'on tue des personnes si on peut ne pas tuer? Should we kill people if we are not obliged to kill? This is proportionality in European laws. So proportionality, safety and security, rights to privacy and data protection, multi-stakeholders and adaptive governance, responsibility and accountability, transparency and explainability, human oversight. That means, I will talk about human oversight at the end, sustainability and the subject of our school, awareness, literacy, fairness and non-discrimination. This is about UNESCO, European Union ethics guidelines, talk about respect for human autonomy, prevention of harm, fairness, explicability. So we can say explainability and explicability. Alors, ce qui n'est pas la même chose, c'est l'interprétabilité et l'explicabilité. Et ça, j'expliquerai. Si vous avez une différence entre explicabilité et explainabilité, je suis preneur. Mais je n'ai pas trouvé. L'interprétabilité et l'explicabilité, c'est pas la même chose. An AI system can be interpretable even if it's a black box. We can interpret the results even if we do not know what is in the box. It is interpretability. We can interpret the results without knowing how it works. Explainability. We can go deeper into the white box and explain how it works, how pipelines is working, how data is collected, how data is transformed, how data is aggregated, etc. How the machine learning models is chosen, etc., etc. So interpretability is not explainability. And if you have difference between explainability and explicability, je suis preneur.
En fait, on peut expliquer la méthode, c'est l'explainability. On peut expliquer les résultats qu'on a interprétés avec un lien avec les inferences. C'est pas pareil.
Et donc, c'est quoi explicabilité, explainability?
De dire, est-ce qu'on est capable de décrire la méthode avec laquelle les données ont été collectées?
Ça, c'est explainability. Donc, c'est mon explicabilité à moi, et l'explicabilité, c'est l'interprétabilité.
Là, c'est d'interpréter, et non seulement interpréter, mais avoir une relation d'inférence ou de causalité.
Causalité, hein?
Entre les résultats qu'on a trouvés entre hypothèses de base.
Mais, et donc, ça, c'est de l'interprétabilité. Ça fait partie de l'analyse causalité. Oui, donc c'est black box.
En fait, c'est indépendamment de black box. Est-ce que les résultats que j'ai obtenus permettent d'expliquer l'hypothèse de base? Là, on parle de l'hypothèse de base.
Donc ça c'est relatif à l'interprétabilité.
Oui, c'est une façon d'aller plus profondément dans l'interprétabilité. C'est pas juste qu'on décrit les résultats qu'on a,
okay.
Mais on arrive à trouver un lien entre les résultats qu'on a trouvés et l'hypothèse de base.
Très bien, très bien. Mais alors, dans les frameworks, they use explainability and explicability interchangeably. But explicability is more related to interpretability and causality. Voilà, causality. For OECD, it is talking about inclusive growth, sustainable development, well-being, respect for the rule of law, human rights, democratic values, transparency, explainability. You see, here we use it, robustness, security and safety, accountability again, and European Union AI Act classifies application, as I told you, facial recognition, social scoring, subliminal, obscure manipulation is scored as high risky applications. And then medical diagnosis, very high risk applications, high risky applications with autonomous vehicle safety, law enforcement, medium risk application, emotional recognition, deepfakes and chatbot, and low risk applications like industrial prognosis, purchase recommendation, or video games. L'Organisation mondiale de la santé, World Health Organization, has also proposed an ethical principles for use of AI, and this is a report of 2024. You are working on healthcare, so you should have this. You should read this report. And principles are protecting autonomy, promote human well-being, human safety, and public interest, ensure transparency, explainability, intelligibility, foster responsibility and accountability, ensure inclusiveness and equity, promote AI that is responsive and sustainable. So you will find the same principles: explainability, transparency, auditability, etc. So either UNESCO, OECD, European Union, or World Health Organization. So ethics is fixed. Ethics, there is no open research, and ethics has been already handled by frameworks. You can say, of course, no. So we know that I will answer, or I will try to discuss, to question this question. RGPD is more used as a framework of privacy than EU AI Act, than OECD. There is a government AI readiness index that rank countries based on governance, vision, governance and ethics and digital capacity, technology sector, and data infrastructure. And when related to governance and ethics, it looks for regulatory and ethical frameworks. And when deepening in these regulatory and ethical frameworks, they use OECD framework. And when dealing with regulatory, they are using World Bank, worldwide governance indicators. And when dealing with cybersecurity, they are using Global Cybersecurity Index. And when dealing with accountability, they use World Bank Index. And here we have the ranking. So France has got +3 points between 2023 and 2024, which is good, because many countries like Finland, yes, has lost in their ranking. Morocco also. That does not mean that countries are not doing efforts, but that means that other countries are doing more focused efforts. United Kingdom in 2024 was better than Republic of Korea. But in 2024, United Kingdom has bad rank than Republic of Korea. That means that there are some countries that are very, very, focused on improving their governance readiness rank. These frameworks still need improvement, or our vision of ethics need to be questioned. Ethics cannot just be checklist oriented, and this has been said also by Professor Shatila. Ethics is not a list of items. C'est pas une checklist l'éthique. Le problème, c'est que les ingénieurs consider ethics like checklists. So we have frameworks. These frameworks will yield checklists. This checklist will be formalized as formulas. Formulas will be formalized as algorithms. Okay, we are ethical. It's not sufficient. It's a bias to think that ethics can be just a checklist with measurements and mathematical. This is algorithmic. L'algorithmic is data ethics, is computational ethics. And computational ethics is just one part of ethics. On ne peut pas algorithmiser l'éthique. Les philosophes, ils s'autoplafondent. Isolated principles. How AI can be ethical if education industry are aethical. So they are using ethics as cosmetic. Ethics washing, like greenwashing. So we cannot just keep our AI models ethical if the industry or organization that use those tools are not ethical. The framework principles can be meaningless, toothless, useless. Explainability, explicability, c'est la même chose. Non, c'est pas la même chose. Mais, they put principles, but no operationalization of those principles. Ethics is being used in place of regulation. Ethics is used in place of regulation. Ethics is being asked to do something it was not designed to do. Gender-biased principles. When we see that 22% of data scientists are women, so those ethics frameworks have been designed by men. So from the beginning, the frameworks are biased. Même si, even if oui, je sais, mais c'est suffisant. C'est suffisant, mais pas nécessaire. C'est-à-dire, even if we have 50-50, we can, bien sûr. C'est peut-être dans la perception aussi des femmes. Il faut changer la perception des hommes et la perception des femmes aussi. Je peux accepter un bas salaire et je peux prendre un bas salaire et l'accepter. Si moi, dans ma perception, c'est ce que je vaux, même si je suis femme, je maintiens ce biais. C'est une partie. J'accepte mon infériorité. Enfin, oui. Comme j'ai dit, il faut des philosophes avec nous. Alors, il a été démontré, it has been demonstrated that there are two ways of reasoning: value-based reasoning and computation reasoning, or calculating reasoning. Men are have more calculating reasoning than value reasoning. This is not me, this is studies. And so women are more sensitive to values. Men are more sensitive to the purpose, le calcul. Et donc, ethics should take both of both reasoning. We cannot just base our ethics on values or on calculating. Both is necessary. As Professor Bloch told about data and knowledge, symbolic and sub-symbolic, we need value, principles, and measurements. But measurements do not replace values. We cannot transfer values to measurement. Algorithmic. AI ethics are more computational ethics that we call algorithmic. So technical solution for technical problems. And now in the industry, there are solutions. I do not want to mention companies, but they sell solutions for ethical measurement. And so we measure that we are fair, we are explainable, we are auditable, we are accountable, etc. We are green, so that's good. And the majority reduce all principles to measurement. Lack of mechanism to reinforce and operationalize those principles. Lack of broader vision of ethics. So ethics in AI, for AI, and of AI are not taken into account. Generally, we are just talking about ethics in AI, which is ethics by design, forgetting ethics of AI, the impact on ecosystem, on individuals, on organization, and ethics for AI, talking about moral agents. We forget these two classes to focus on ethics in AI by algorithmic, computational ethics. So we are doing computational ethics, which is part of ethics in AI, and we forgot all other parts of ethics in AI and all parts of ethics for AI and of AI, which is very biased vision. Procedural ethics is often cosmetics. Companies can enjoy appearance without substance, organization in general, and government in general. And ethics washing, principle washing, ethics become a tool for self-regulation and even worse, for protecting companies and organizations in general against criticism. Ethics remain focused on the individual while the risks are systemic. And trustworthy AI often masks optimization. So the purpose of organization when they talk about trustworthy AI is just optimizing the result, not the justice, itself. So it is capitalistic view of trustworthy AI, which is not sufficient. So I told about human oversight. Human oversight is part of trustworthiness, and we can talk about keep the human in the loop. For example, a doctor reviewing AI-generated diagnosis before action. So we do not, as Virginia Dignam says, and Mohammed has many papers with Virginia. And Virginia was part of HLEG, high-level expert group of European Union Commission that have been working on AI trustworthy guidelines. And she said, we cannot delegate moral responsibility to machine. It is always human who are accountable. And so human in the loop, the human is accountable and should review the results of the model. Human on the loop, a person monitoring an autonomous drone in real time. So preventing evasion attack, for example. And human in the command, human can override, shut down permanently or decommission permanently a system like Microsoft did with the Tay chatbot. They decommissioned it after 24 hours. So we should keep human oversight, and which is part of hybriding AI intelligence with human intelligence. So Professor Bloch told about hybriding data and knowledge, subsymbolic with machine learning, deep learning, and symbolic AI with expert system, knowledge-based graph, descriptive logic, etc. This is hybridation between two kinds of reasoning, machine learning and statistical learning, which are not the same, inductive and deductive, abductive reasoning also, when we are looking for causality and for looking for facts, generating, causing, and another hybridization is hybriding human intelligence with artificial intelligence with this human oversight. So research roadmap. Okay, is this part of engineering or there is research behind? Ouais, c'est le dernier slide. Alors, quelles sont les perspectives de recherche? En fait, now that we have fine-grained classification of information, PII, SPI, behavioral biometric SPI, biological biometric SPI, PHI, collective identity, behavioral identity, sensitive information, model, profiling sensitive information, model sensitive information. So we can do fine-grained SPI-aware data and AI governance. That means that we can construct a fine-grained taxonomy, and this taxonomy will provide tagging, fine-grained tagging. So you remember when I've shown you metadata as part of governance? So we will have data catalogs with very, very fine-grained tagging, and we can build on those tagging. Security, and we can mask sensitive data, fine-grained sensitive data related to roles. For example, if we have an external third party that participated in the project, I can either open biometric or not, crypt biometric or pseudonymized biometric or anonymized biometric. You know the difference between pseudonymization and anonymization? Who knows the difference? L'anonymisation, c'est une fonction non bijective. When we anonymize, when we anonymize, we cannot go back. We cannot roll back anonymization. So it's permanent. But when we pseudonymize, we can go back. So why we pourquoi on pseudonymise? Il faut que c'est l'heure de manger. c'est mon ordre biologique qui parle. Biological behavior. For example, when we give my data, customer data to some society, to some company, to make some marketing segmentation. If I anonymize, I cannot go back to identifying my customers to act in reality with my customers. So I just do pseudonymization. Like this, the company that work with me cannot access directly to personal information. But myself, when I get the segmentations with some clustering algorithm, let's say, I can roll back this pseudonymization and recover, re-identify personal information, so I can call my customers and do my best to retain my customer, to not let him churn, etc., etc. So fine-grained tagging with those classification will help me fine-grain data security, but not only. I can make automatic SPI detection and tagging. So I can run algorithms to infer classes, SPI, PII, Biometric, PIHI, etc. Tag automatically all my data and tag automatically all dependent data of my initial training data. And tag all my sensitive pipelines automatically, which we call data lineage. With algorithms, of course, with NLP algorithms, for example, because it's not obvious all time to classify. We talk about homomorphism encryption. We are talking about the system, the crypto system endomorph crypto system. You know about this? Endomorph crypto system. I told about pseudonymization, yeah? When I do some customer segmentation. But if I want to encrypt my data and I want to apply data mining or machine learning on my data, if data is encrypted, does machine learning works on encrypted data? Some encryption algorithms work. Encryption algorithms that maintain distances between data. So if I am Karim and you are, your name? Louis. The distance between us, if it is maintained when I encrypt Karim and Louis information, I mean, it's fair. Means, for example, will work if distances are maintained. So if we detect those SPI and subclasses, we can apply this endomorphic crypto system. They maintain distances, and all clustering algorithms, etc., will continue to work. But if we do not detect that those data are sensitive, we do not encrypt them, and we can have problems with security and compliance and so on and so forth. So there are techniques to protect those data, to protect learning on those data. But if we are not aware of what we are manipulating, we can have big problems. Data minimization, lineage propagation of SPI metadata. What I told you that we can detect dependence between data, other data, scripts, pipeline, dashboards, and we can propagate all this metadata automatically. We can automatize compliance to regulation. We can score ethical risk and monitor the scores. We can enable human oversights, explainable human oversights for auditors, etc., etc. Many good opportunities when we are aware about those dimensions. So some challenges: fine-grained SPI taxonomy construction, mapping from legal cultural norms to formal taxonomies, privacy-aware machine learning pipelines, SPI-aware continuous integration. And Fabrice yesterday told you about what is continuous integration. So there is continuous integration, continuous delivery, continuous deployment. And so detecting compliance of these data ops pipelines, auto-tagging SPI, can LLM reliably detect domain-specific SPI fields with zero-shot classification without giving him inputs? Re-identification risk metrics. You read some in the social networks that some people, some users of chatbot could recover some personal information that ChatGPT has trained itself on it. So this is a risk. If an LLM, for example, train itself on SPI, to be able to detect if we can re-identify information in this training data. Model sensitivity to SPL attributes. Can a model leak sensitive data it was trained on? And so all these are very, very good perspectives to work on or to be at least aware of. Thank you very much. No worries. I will keep it available. J'ai pas parlé de Grok. J'ai parlé de DeepSeek. I didn't talk about Grok. I talk about DeepSeek. No, DeepSeek at the beginning, it was announced that it is open source. But later on, I heard that it is not open source at all. No, I did not talk about Grok. No, it is my pronunciation, perhaps.
Many often laws often have political reasons. For example, about previous one about Sora or the product of ChatGPT. France was one of the last countries to allow people to use it, and we have many something like this in about research. And sometimes for collecting data sets, we have many rules and limitations for collecting data, and at the end, it discourages us, and we lost it and finish that research. So in this situation, I respect all of the laws, okay? But some of the rules bothering researchers.
Of course.
Because or a final decision is positive. What rules limit us? What is your opinion about that? And how should we deal with this situation? And do you agree with that? Sometimes we convert for research to countries with lower or fewer laws, and after that, collect our result, and after that, convert it to the first countries. I don't know if you understand.
Always regulation are not that fast as technology. Technology is faster, and so regulation have a very, very slow pace. You know the founder of Free? I forgot the name of the founder of Free. Oui, oui, c'est ça, c'est ça. Niel. Alors,
Free operating.
yes, yes. And this guy tells one day that innovation is at the neighbor or of legal aspects. I mean, all his innovation, like Minitel Rose, was really in the boundary of legal aspects. Innovation it's tricky to make innovation and respect rules. It's very, very tricky. For example, in one project, I have papers on technical aspect, and in one project, when we developed the deep learning models for mining, for saving miners, for miners' safety in mines, 1 kilometer of 1 kilometer deep. We have used movies to train our models, movies of mines. And we have chosen movies from Africa, from South America, to have dark skin. Because if we take just Canadian or Australian, it will not make it. We will have ethnic bias. And we have contacted the producers of these movies to tell them, we are doing research, please give us agreement to use movies to train our models. Their answers was, niet. You should pay to use our movies. So please contact production company in Morocco. This company will contact us, will pay royalties, and then you. And so each innovation is confronted to this kind of legal issues. Of course, researchers should respect or at least should bargain with laws. It's very open question. I will not tell you not to respect laws, but if you publish some data set that is not your property, you will have serious problems, and your responsible will have serious problem.
So you can discuss during lunch if you want, because we still have 1 hour and then the next just 2 points that are quite funny based on the stuff. First, the image. If you see the image here, the image that was put here, this was the original image put on Sky, but we changed it.
Okay.
This is not the one that we have now.
Okay.
Why? Because someone, I don't know who, but when we sent that to Sky, said, we are organizing a summer school with Morocco and France, and this is AI on health, it generates this image.
It is biased.
Lot of bias.
It is biased.
So that we said, okay, guys, we can change that. Typically, so you see, this is the original image that someone put on the website. I don't know. I don't want to know who did that, but this is not Fabrice and myself. I can tell you because we are not. And then we asked to change that. So that. And another comment, because yesterday I came with books, but you mentioned Virginia. This book is done with books in Virginia, and there are a lot of things like computational law and ethics, and this is good for. And still, so when we finish here, it's not finished, so we have lunch, we can still discuss. We have breaks after, we can still discuss this point. And tomorrow we have also a presentation from you. I think that will be also interesting to follow. Okay. So thank you again.
Thank you.
I think people are already waiting.